We are go.
All right. Welcome back, everybody, to the Explore Simplexity podcast. Today's topic is the Fermi Paradox.
Yes, one of my favorite topics. Before we get into the Fermi Paradox, though, what's your opinion on this on extraterrestrial life in general? Is it out there? Is it not? Do you have an opinion?
I think there's a non-zero probability.
Mm-hmm.
There's a possibility for sure.
Yeah. Well, and then, the conversation can be different, too, depending on if you're doing, the SETI thing, which is the search for intelligent life.
Right.
But I think there's a pretty high chance that there's probably some microbes out there somewhere in a different galaxy.
Yeah, well, and that's another thing. I guess we're kind of getting into the Fermi Paradox, but assuming sane, rational, non-time bendy universe, which, anyways, if there are, let's say, X civilizations in the galaxy, one of them had to be first, right? You just order them. One of them had to be first,
right? And
it's possible that maybe it's us.
Yeah, statistically, I'm not totally on board with that. Okay, well, I'm trying to set basically the boundaries on kind of what we're working with. I think there's a really high probability of extraterrestrial life somewhere in the universe, for sure. Universe is big. Galaxy, Milky Way galaxy, much, much smaller. But our chances of actually interacting with, let's say, life in the Andromeda galaxy, really difficult. It's very far, far away. The space between galaxies is crazy. Unless you did some kind of Deep Space Nine, wormhole into the Delta Quadrant. But that was still within the galaxy.
Right.
And they were just talking about quadrants within
Quadrants of the galaxy.
Now, there's 100 trillion galaxies, all at different stages of development.
Intergalactic space travel.
Right. So, just the sheer numbers, if we say the universe, I'm almost 100%. There's something out there that resembles something like human intelligence. Now, if we just say, okay, anyone we hope to interact with in any kind of reasonable, assuming light speed is the universal speed limit, the Milky Way galaxy is still pretty big, but maybe that's where we should limit our questions. Does that seem reasonable for today?
The sky's the limit.
The sky is the limit. Well, I guess I'm trying to set up my boundaries. So I like to think about Milky Way life, because that's something that it's still 100 billion light years across, I think. Or I don't know the exact numbers, but it's very far.
So we're not talking about other galaxies, and we're not talking about interdimensional aliens.
Well, you mentioned interdimensionality, and then also multiverses, right? So we're one bubble in another bubble that's connected to another universe, and then this gets it gets really silly. Basically, it's what's that one movie with the hot dog fingers?
Oh yeah, Everything Everywhere.
Yes. There's none of that going on.
Link the DVD in the description.
It's a really good one.
I love that movie.
Yeah. But that's talking about how everything has happened, and then every possibility in some universe has occurred, right?
Right.
So if that's what you want to talk about philosophically, then does extraterrestrial life exist? Isn't that interesting of a question? Because yes, there's probably things you can't even imagine in that kind of understanding. But just classical, Einsteinian understanding of physics, let's just focus on the Milky Way. This is kind of what, I forgot his first name, but the first person to try to actually address this was Drake, and the Drake equation. Have you heard of that?
Yeah. So the Drake equation says, okay, how many stars are there in the galaxy? And then how many planets are there on average per star? How many of those planets are capable of supporting life? And then how many of those planets actually have life? And you should be able to compute the expected value of life in the galaxy.
Yeah. Right, and I think it's pretty straightforward concept. The tricky part is knowing what coefficient to put in front of each one of those parameters.
Right, and that's what's kind of a little, And maybe NASA's getting closer to figuring out those numbers.
They are. Well, they're getting very close to figuring out this planet stuff. So they're finding new planets all the time.
Yeah, and they're like able to detect like gravity waves that reveal the presence of planets even though you can't see them.
There's lots of different ways. I think the most common one they use is occlusion. So when like a planet orbits around the star and the star gets dim by like a fraction of a percent, it's because the light is being blocked by the planet that's in front of it. And they can detect this somehow. That's one of the most common ones. But then they have some kind of other light diffracting thing based on some gravitational effects that the planets are having. They have a lot of cool ways they can do it. But basically what they're finding is almost every single star out there has some kind of thing orbiting it.
Yeah.
It's like way more common than they thought. The big problem is they've only been able to detect like Jupiter-sized planets because they're easier to see. Because they're so.
I was just remembering Terrence McKenna's. What's that guy's name who was on Joe Rogan?
Oh no, Howard, Terrence Howard. Did I send you that? Did you watch that?
I did.
Okay,
that was a mind bending. For sure.
Yeah, that was something. He's got some interesting ideas. I like that stuff, but then it's just too much at some point. The woo woo gets too woo, But I like thinking about those
Sorry for the segue.
Yeah. Are you saying that
I'll link it in the description?
Am I going off the rails?
No. You were just talking about like planets and he was showing this thing about how like gravity fields intersect and that's like what causes planets to form.
Right. So he had like this 6 vortex design that can cause the hexagon on top of Saturn, and you don't need gravity. It looked like they just made a movie or something, but I don't know.
But so when you said there's evidence for lots of planets, that image just popped into my head.
Gotcha. Yeah. So there's tons of planets. When Drake did his thing, I don't think he expected that many because we just hadn't seen them. There was no way to observe them, and now they have techniques to detect these things. And basically, there's like always a Jupiter-sized, not always, but there's lots of Jupiter-sized planets out there. Mostly because we're biased into our technology, and that's what we can actually detect.
Right.
It's harder to detect Mercury's like all the way across the galaxy.
Right.
The other interesting thing is that a Jupiter-sized planet has also been thought as to have one of those in your solar system to be essential for life to evolve long enough on a planet. And the idea is that these large Jupiter-sized planets are kind of like a sentinel for the solar system. So if you have comets and asteroids going everywhere, it just sucks up the things that could really mess you up on Earth.
Right.
So if you don't have a Jupiter-sized planet to do that for you, that's one thing that you need. And what's interesting is they've been adding a lot more things to the Drake equation, such as that.
Okay.
And I don't know how true this one is, but I've also heard like having a moon and like a tilted axis allows for seasons, and that could be critical.
Or tides too.
Or tides, or I don't know. There's all these things that seems like the Goldilocks zone is becoming more and more picky about what works. Yeah, but so that kind of goes into the argument, that you were talking about, that there has to be that maybe it's extremely rare, and even though there's so many billions of stars, that all the conditions to get this perfect Goldilocks conditions, maybe it's literally 1 in 100 billion, maybe. I don't know. That just seems like we won the jackpot like 30 times in a row or something. I don't know what the stats are, but that seems pretty wild.
Yeah. And there's also some fine tuning stuff too, where people talk about like the like boson distribution and like because if it's too high, then you get too much matter, and if it's too low, then you'll just have too much gas. And so there's also the tuning of the universe itself.
Yeah.
That allows for matter, which allows for molecules, which allows for
Right.
DNA to exist.
There were some constants that they talk about near the Big Bang where, like, if something was off by, like, a fraction of a percent, the whole universe just collapses or doesn't even start.
Mm-hmm.
There's not just, like, one of these. There's, like, several of these, like, universal parameters that are tuned just so. But then the question is, the only way that the universe could exist if it was tuned just so. So the fact that we're here and then it's tuned that way maybe isn't surprising because we wouldn't have known about it otherwise if it wasn't tuned just so.
Well,
am I sounding too much like Terrence now?
No. So I was taking it two ways. So
Yeah.
one idea is that there's a creator,
Mm-hmm.
and then the other idea is, it's a simulation.
Yeah.
We've talked about. I
Yeah,
think we talked
that's
about simulation theory.
We may have briefly. It's really interesting. It seems like a fun woo-woo thing. There was one person, I forgot her name. She was on the World Science Festival, and she had an approach to where she was actually trying to look for, like, if you think of the universe as like an information system,
mm-hmm.
the amount of information to be contained in the whole universe is, like, unthinkable. So as a computer program, what you try to do is compress things or do shortcuts to save time or data information.
Mm-hmm.
And so I'm not a physicist and I don't understand all the, like, details that go into it, but the idea was to look for those kinds of clues that maybe there's some shortcuts in the information processing that's happening.
Mm-hmm.
And then if you find something like a glitch in the matrix, basically,
mm-hmm.
right? The deja vu thing, but more on, like, a physics level. If you see some evidence of that, then that I could buy into the whole simulation idea.
Mm-hmm.
But other than that, it doesn't appeal to me as much.
Or doesn't seem likely.
It doesn't seem likely, and then I guess that's what I mean by appeal. It's I wouldn't put my money on that one,
mm-hmm.
personally.
So the Fermi Paradox is the question,
mm-hmm.
why are there no aliens?
Now, where are they?
Where are the aliens?
All right, so assuming we've worked out the numbers and the stats, seem like there's, like, billions of planets that are in this Goldilocks zone that could potentially do it. And the other huge thing is not just the quantity of locations that can occur, but the amount of time that you need to, like, evolve on Earth. Or like humans. What was it? How long is it? A couple 100 million years or something for humans to get intelligent or past Neanderthals?
Are we counting Lucy or?
I don't know. But point is,
long time.
Not that. No, the point is, it's not that
Relatively
long.
not long.
Yeah. And that at any time, one of these 100 billion planets could have just had a lucky little short amount of time to become smart.
Yeah.
So the tricky thing when thinking about the Fermi paradox is just have an intuitive grasp on the scale of the numbers we're talking about here. And I'm not even giving, like, firm numbers. One, I don't know them specifically off the top of my head. And number two, it's almost like 10 trillion might as well be 10 quadrillion in terms of, like, the way I think about things.
Yeah. So for people who don't know, we were talking about the Drake equation. And depending on the numbers you use, there might be an expected value of 10 billion intelligent civilizations in the galaxy, or 0. You know, so I mean, it's pretty. There's a pretty wide range of values, and one way of sort of adding to this Drake equation, if you want to call it that, is these phases. I think they call them bottlenecks. These bottlenecks of evolutionary theory, where you have to have the Cambrian explosion to get from, like, single cell to multiple cells, and then you have to have a nervous system, and then you have to have brains, and then you have to have tools,
right?
And then you get intelligent life. And so there's, like, bottlenecks that have to happen even after there's life. So to have intelligent civilization requires extra parameters or probabilities.
Absolutely. I think they're called filters.
That's great
filters.
filters.
Same thing. Yeah, the bottlenecks. But
And
basically,
for example,
yeah.
some people argue that if the dinosaurs never went extinct, mammals wouldn't have arisen.
Yeah, right. And I think those are really interesting parameters to talk about. Is what were necessary steps and what were just like we just happened to get there. And so maybe we had to go through this reptile thing in that wiping out everything at that point, but maintaining some DNA and life to resurge. Maybe that was absolutely essential.
Right.
And just we don't know enough about the inner workings of biology and evolution to predict that accurately.
Right. So going back to your point, like there might be a planet with like bacteria, and that's it. That's the extent of life on that planet. And so the Fermi Paradox is, where's the intelligent life? There's probably life out there, maybe. There's also this panspermia idea. I don't want to muddy the water in concepts. But
we'll definitely get back to that because that could be another interesting thing. So there's lots of stages. So let's talk about maybe some of the main ones. I think it was going from just having these amino acids being formed, like organic material from like just particles.
The primordial soup.
The primordial sludge. Yeah. The world was void and without form. Is that civilization?
Oh, yeah.
Intro.
So, yes.
That,
Yes.
That always stuck out in my mind. When I think about like life evolving, I always think about that. The earth is like this crusted lava thing. And they go through the whole thing. Start out as cavemen. But
2001.
Yes. So the first thing
I just saw the new Planet of the Apes. Sorry, too many tangents.
No, it's all good. What they have a new one?
Yeah, they did a remake of the Planet of the Apes.
Well, they did that a while ago.
Yeah, but the latest one's called The Kingdom of the Planet of the Apes.
Oh gosh. So what? This is like the 5th sequel or something?
Something like
I don't
that.
know.
Yeah.
I'll lose track. I love the first one, and then it got a little weird. The slow pacing.
There's some callbacks to Charlton Heston and
Okay.
a human doll that says "Mama."
Right. Yeah, that was really interesting. And then even the ape government was trying to hide the truth to protect their society.
Right, the forbidden zone.
Yeah. Just like we're not gonna go there. Interesting parallels.
And I was just talking with some friends. You probably knew this, but the original Planet of the Apes was written by Rod Serling.
Ah, makes sense. That could have been a Twilight Zone episode.
For sure. It's an extended Twilight Zone episode.
Yeah,
It's exactly what it is.
Yeah, I didn't realize it.
Just like the pacing.
Yeah. It's so slow, too, at the beginning. And eerie. Yeah, it's got that Twilight Zone feel. Okay, so I was going to go back to maybe the first bottleneck or filter. And this idea is, how do you get organic amino acids out of just like basic elements? And they've done this in the lab, and it's proof of concept. There's some famous experiment where you just put these like inorganic molecules in a beaker, and then you shock it with like electricity. And the idea is that if there's like lightning or some kind of energy being put into there, you can spontaneously form these kinds of molecules.
It's alive!
So they basically said,
Igor, flip the switch!
If you just get like water and like nitrogen or all these like oxygen and all these basic things, and you shock it with a lightning bolt, they can spontaneously form these things. So basically, it's proof of concept of that this can happen spontaneously on these planets. How often it happens or what are the conditions? It's a little more tricky. So after you get these amino acids, then it's like more complex molecules, and eventually you get these organelles. And then like a cell itself is like a combination of multiple different smaller organisms. And so at some point during evolution, like the mitochondria was like doing its own thing. And then all of these other different things, like the ribosomes, lysosomes, ER. I'm doing broad strokes on this, but the idea is they're kind of separate, but then at some point they became a cell, like a symbiotic thing. That's surrounded by.
Well, I've heard that your mitochondria actually has separate DNA.
It does. Absolutely. And that's maybe some evidence for that.
Mm-hmm.
So we always think about multicellular organisms, but the cell itself is like a multi-organelle organism.
Multi-cell thing. Yeah.
Or, yeah, within the cell.
Mm-hmm.
And again, I love this kind of scaling and recursion that's happening. Because then I have multicellular organisms. That's really hard to do.
Mm-hmm.
You know what the coefficient for that is in this Drake equation. I have no idea, but I'm sure it's not easy.
Mm-hmm.
And then as you go up and up, all the way to human intelligent life, what's fascinating is if you look at the amount of time it takes for things to develop, in terms of evolution, it's like the first step takes like 80% of the time.
Mm-hmm.
You know, it's just like that first step is just ridiculously like hard to do.
Right, like 80% of the time was one cell going to
Multi-cell.
Yeah.
Right. And that's just like ridiculous. But from going from like Lucy or like Neanderthal to Homo sapien, it's just like nothing.
Yeah.
And the capacity is just staggering.
I think what I really liked, so Carl Sagan's Cosmos has this thing called the cosmic calendar.
Mm-hmm.
And he like says, okay, if we take the origin of the universe being to now being a year,
Mm-hmm.
you know, humans are like December 31st,
Mm-hmm.
you know, the last 30 seconds before midnight or something like that.
Yeah. Yes, it's beautiful analogy because it really makes you understand how small of a time it is.
Right.
For something so like incredible to occur.
Mm-hmm.
Yeah. So okay. So then going back to the Fermi Paradox, these things are rare, but there's so many planets, and there could be so many things that are needed for life. But if there was, right, where are they? Why don't we see any evidence of technological civilizations that could either A, emit radio signals, like some kind of artificial signal that we can pick up,
Like the SETI stuff.
yeah,
Or contact. I love that.
yeah. So there's like, okay, what are we looking for, like in the universe? Like, I don't think they're going to be sending, like, we're going to be finding some alien artifact that's just going to float to Earth, right? It's probably going to be some signal that they're emitting.
An obelisk.
Yeah, but it's probably going to be some signal that's like a byproduct of their technology.
Mm-hmm. Right. So in Contact, there's this scene where they get like this radio signal from space,
Mm-hmm.
and it has this encoded, television signal of Hitler opening the Olympics.
Yes. Right.
And the people start freaking out, like, what is this?
Yeah.
And they were saying, well, that's the first radio signal that went into outer space.
Right.
So that in the movie, like the aliens heard the signal and they sent it back saying, we got your message.
Right. They weren't endorsing Hitler's campaign.
Right. So
Bad joke.
But yeah, I mean, that was part of the drama. But
Right.
But the point is, like, we've been sending radio, television, like, we just been broadcasting all sorts of signals for
Correct.
decades now, centuries.
Yeah. So let's say 1900s.
Yeah.
Let's say, so like 100 years, 120 years.
Mm-hmm.
So those signals travel at the speed of light. It is a form of electromagnetic radiation. So 120 light years is how far it's traveled from the very first thing that we've sent. And I think the galaxy is like 100 billion light years across. And so it's been 120. So I don't know what percent that is, but it's basically we just like did a little fart
Right.
around our star. I think Alpha Centauri, which is the closest, is like 7 light years away.
Okay.
So we've definitely hit some.
Mm-hmm.
But in terms of the statistics and the numbers, like, first they have to be that close to us. And the probability of that happening, I don't know, maybe it's high and low. Maybe that little area of the galaxy is kind of a birthing zone. Who knows?
Yeah.
I mean,
well, but conversely, the idea is if alien civilizations have radio technology,
Mm-hmm.
whenever they invented it, it would be emanating out from them.
even if they were long gone too.
Yeah.
Yes,
And as far as we know, like, SETI hasn't picked anything up.
Yeah, exactly. So this is kind of interesting thing too, is that the time duration, right? So why did we evolve intelligence at this specific point in time, like in terms of years? like maybe there could have been a civilization, an intelligent civilization that arose like 2 billion years ago and then came to do all this crazy stuff that we've done in a short amount of time. And they started sending out signals that maybe they lasted 200, 300 years, and then they stopped sending signals. So there's just like maybe a small blip of when you might be able to even see that they're there.
Mm-hmm.
And that comes to kind of one of the scary concepts of the Fermi Paradox, which is one of the reasons we're not seeing them is that they just simply haven't survived,
right,
to stabilize themselves for a long-term period of time.
Right. Well, that's one of the things Carl Sagan, I guess Jordan Peterson for that matter, is concerned or was concerned about atomic bombs.
Mm-hmm. Mm-hmm.
It's like you have the capacity to wipe out all life on the planet.
Yeah.
And the suggestion is maybe these other civilizations didn't make it.
Mm-hmm.
And I guess it's kind of Elon Musk's deal. It's like, hey, let's colonize Mars in case, things go sour on Earth. We got a backup plan.
Absolutely. Yeah. Well, the first thing I think he did like the electric car thing because he was concerned about like global warming and wiping.
No, first it was PayPal. He did PayPal first.
Well, yeah. Well, he just was trying to make some money. I think at that point he was just getting in there and offering a great service to people with PayPal. But I think everything after that, mostly, he's trying to like push humanity into a positive direction.
Mm-hmm.
Right.
Yeah.
Yeah. So it was like we're gonna do the electric cars to try to reduce the CO2 footprint. And then it's like, okay, well, maybe we're past that thing, or if that's even an issue anymore. So then he goes to space to go like colonize Mars to save humanity from itself. And then what's his next step? Merge your consciousness with the computers because that's right. The next existential threat.
The uplink,
yeah, Neuralink.
Neuralink.
So I always thought that was funny. It's like he goes down one way. It's like, oh no, too late for that. Going to Mars, no, too late. Oh, AI is gonna come. Oh, we got to merge with that. And who knows what's gonna happen next time? It's gonna be some threat.
Yeah, for sure. Well, it's interesting because some people think like Elon Musk is Satoshi Nakamoto, who started Bitcoin.
Oh my gosh, yeah. He's just one man. You can only do so many things, right?
Although he does have an impressive resume.
Yeah, for sure. Yeah. That's actually an interesting question, right? So let's say we did, just as a fun side thing, let's say we did have some contact and there was like a take me to your leader. Like who would be representing Earth? I think Elon Musk would be on a
maybe.
Candidate.
Could be.
Maybe the Dalai Lama.
Or right. I mean, that's Carl Sagan's question.
Yeah,
who
right.
speaks for Earth?
Right. And there was like a committee in that contact, right?
Mm-hmm.
Right. Very interesting.
And some people think Elon Musk is an alien.
Yes, like Men in Black. Michael Jackson's an alien too. They're monitoring them. Okay, so so maybe it's just this historical thing we've seen through evolution where humankind have been pretty brutal. Wars have just been just as common throughout history as anything else. Mm-hmm. And it's like steady.
Since tribal days.
Yeah, it's just, and there's
in the DNA.
There's no reason to think that it's just going to be, okay, we figured it out and we're all going to live in a utopia. Like that seems pretty naive. Possible. Don't want to be too cynical. But if you just look at the historical record. So it seems like a good chance that we have the technology to wipe us out, ourselves out. Maybe that's a reason that we're not seeing the aliens. But if there were like these intelligent civilizations that came up and lasted a couple hundred years, there could be like the radio transmissions that could be just in like 120 or 200 years, little pockets, like little waves. And if there's lots of them, maybe they're just emanating from everywhere and you just have to be lucky to be far enough away for when they were sending out signals and that you can catch it. Mm-hmm. So it's possible. I think that's what SETI was basically trying to do, is listen to all these things. Kind of a depressing thought, but it makes a lot of sense. Another idea that I like, which I don't know, I just kind of thought of this one on my own, was why, like, what's so important about just spreading humanity's DNA just across the galaxy? Like, what's the end goal here? What is the point of setting up, being stable, and expanding and conquering and taking planets? And what's the whole point?
United Federation of Planets to seek out new life and new civilizations.
Yeah, but
to boldly go where no one has gone before.
That's a real question, though.
I know.
Yeah.
That is an answer.
Yeah. Okay.
It's the exploration story.
Yeah.
Adventure story.
Right. So, okay. What if there was
No, well, here's a question. Like, if Elon Musk had this, Mars colonization thing going, would you sign up to go?
Not tomorrow.
Well, okay, but I mean, just
if it was possible and safe and whatever, all that.
Yeah,
that'd be interesting.
There's like this spirit of adventure and like you're living this Star Trek kind of life, and
it's super cool. Okay, so what you're saying is maybe that sense of adventure is almost just as ingrained in our history of humanity as like warfare and conflict. It could be.
Yeah.
Okay, so maybe that's why you would expect an intelligent civilization to just spread everywhere, because they're just curious and they want to know more.
Yeah, well, I was reading these quotes from Einstein, and he essentially said same thing as Carl Sagan, that like the most beautiful, mystical, reverent sense of the universe is what drives all true art and science. This just curiosity and wonder and just like what's going on. And having that be, the highest, noblest motive.
Yeah. Okay. Well, okay. So this was. I see what you're saying, and I'm not refuting that. I think I like that concept, but my idea was one that would try to avoid like self-destruction of why we haven't seen them. Another one would be it's more of like they've reached a sense of enlightenment. Where their civilization or society is no longer interested in jizzing on the entire galaxy and like just spreading as far as it can go and set up shop and flags on every single planet across the galaxy. Maybe they're like, yeah, maybe that's not what we're interested in. Maybe we want to live in the Garden of Eden and then not do this stuff.
And there could be like the Star Trek thing. So there's this idea called the Prime Directive, and the idea is if you're a spacefaring civilization, you do not interfere with the evolution of primitive civilizations, and then once they develop space travel, then you make first contact.
Right. Yeah.
But this is science fiction, but it's an interesting idea. Like, what if there's some sort of like ethic of non-interference, and they certainly would have the technology to evade our detection, like our technological detection.
Could be that's a third idea, is that they are everywhere, but there's some kind of organized way to hide themselves for whatever reason, for this to not interfere with the natural development. But so I mean, Star Trek is great because it's talked about so many concepts. But there was a society on a planet who was basically living in like an agrarian basic society without technology. And Picard went down there and he like fell in love with this girl there. Remember that episode?
And is it the one we got like, transported back in time and had this like dream of a lifetime? And
yeah, that was it. Maybe I'm thinking of another episode.
You learned to play the flute?
I think so. But basically, I think the society that was there was like, oh yes, we know like, dilithium crystal technology and warp speed and all this, but we're just not interested in that. We like this simple life. And so it's like they have the technology capacity, and they've been there for like 1 million years.
Oh, I think that was the one of the movies too, where they had this like Garden of Eden
the face
planet.
stretching.
Yeah.
Maybe that was it.
Yeah, and they're like, yeah, we have this technology, but we prefer to just chill.
Right. So, anyways, that was a big lead up to say that I think that could be another explanation to why we don't see overt signs of other civilizations. Maybe the natural progression is, why do we want to just send a thing out like crazy? Like, what's the point? What is the end goal, like philosophically? Like, is that necessary? Maybe it is based on this. You brought up this idea of adventure and curiosity.
Mm-hmm. And there's another idea too, that if it is just curiosity, like, why not just send probes to collect data and send it back? Like, you don't have to be here in person.
Mm-hmm. Maybe that's what the UFOs are.
Could be.
Yeah, extraterrestrial probes.
Right. Or another idea is that they're sort of like gifts. Like they're saying, oh yeah, here's some free tech. And then, upgrade your civilization and we'll give you a little more free tech.
Yeah.
Like breadcrumbing your way
Maybe.
into the galaxy.
Yeah, who knows? I mean, I feel like they'd probably be more explicit if that's what their goal was. And the other analogy is if there was an intelligence, and the argument is mostly that when these intelligence develop, it's going to be like millions of years difference. And if you can imagine like a alien civilization that has a million years on us in terms of technological development,
right?
It's like there would be no, like, what's the point?
Mm-hmm.
So we'd maybe just be as interesting as like an anthill or something,
right?
And maybe it's just like a fun research project. They're coming down and like studying, like we study the chimps in the jungle.
Mm-hmm. Mm-hmm.
That's crazy. But the fact that so far there's literally zero evidence of transmissions. So there's other ideas too. So if you're familiar with the concept of the Dyson sphere?
Yeah.
So I heard something, it was on a podcast, or I read an article about there could be a way to technically try to detect Dyson spheres. And that could be another way to...
Oh, yeah. Wasn't there like some typology of like a type 1 civilization, type 2 civilization?
Yes. How much energy you can harvest and collect.
Yeah. I don't remember what it is exactly, but like I think the second level, maybe the third level was the Dyson sphere level.
Right, where you can collect 100% of the energy coming from a star.
Mm-hmm.
Yeah, and that was almost like a necessary, just if you take it logically from energy consumption and usage, that would be where it is. And they're saying, okay, so if that's the case, we should be able to detect Dyson spheres out there. And someone had some idea of how to do it. Just like for a long time, like black holes were theorized, but we never saw one. But then they found out some really interesting ways to detect them with light refract or bending and curvature, and using I don't know, but someone came up with a way to potentially look at Dyson spheres. And there's like other things, like other kind of remnants, like space junk, maybe that we can look for. The primary thing are these radio waves, because that's probably the simplest, easiest, and the fastest to travel. But maybe there could be other things to look for that we just don't have the technology to detect.
Mm-hmm.
Yeah. And if it's too hard to just detect remnants of their presence or some kind of indication that something is artificial, maybe if they had the capacity, they're just not interested in A, interfering because of some like prime directive, or B, just like what's the point? So there's no effort on their side potentially to say hello.
And then, according to Graham Hancock, it's the ancient alien hypothesis.
Mm-hmm. Yes, the panspermia. We can come back to that one, I guess.
Yeah. So there's two versions of panspermia. So one version is the idea that, there was a life-bearing planet that, exploded, or maybe some colonizers, sent out probes in like asteroids.
Right.
And then those crashed on Earth and seeded the planet.
Right.
And so instead of primordial soup starting it, it's like this seed from another world that started it.
Yeah. And that kind of idea also shortens the requirement that you have to start from scratch when it comes to the evolution of these things. Mm-hmm. Like maybe the amino acids developed and you had some kind of rudimentary DNA stuff.
In like space dust or
and
asteroids.
Then the thing had an impact and exploded, and then that seeded something else. So it's like they gave them all that work to get to that stage, just kind of jump-started by seeding it.
Yeah. Have you seen the Prometheus movie?
I haven't. Is that the alien one?
Yeah, it's like the prequel, or I don't know where it is in the alien world, but so it's essentially starts out where these, I forget what they're called, founders or something like that, engineers, they go to this planet, presumably Earth, and this guy just like drinks this, toxin and like melts into the water. And the idea is that like he's seeding the planet with his own DNA.
Yeah.
And that like kicks off the evolution.
Okay.
Because the goo is supposed to like have this accelerated evolution. Anyways, so that's like a pop culture reference to it.
Yeah, absolutely. But there's maybe some legitimacy to that idea of just jump starting it.
And then the ancient astronaut idea is that not only are there aliens, but they've been here before, and like Stargate kind of idea, like our civilization was started by them. Like we are the biological like sculptures of alien civilizations.
Yeah, no, that idea has always fascinated me, and I just think that like looking at like these pictures of different kinds of carvings of ancient civilizations, some of them are kind of spooky, and most of them have been debunked in terms of like what probably these things are meaning, but some of them are just like, that's just a little too weird. It's enough to at least pique my adventurous curiosity spirit to think that it could be a real possibility.
If nothing else, I feel like if we're able to like imagine and extrapolate like science fiction scenarios, like if nothing else, maybe cavemen were able to imagine such things.
Cavemen being able to imagine science fiction scenarios?
Well, what we would call science fiction, beings in the stars. I mean, that's what when they, saw the planets, they thought they were gods, at least in classical civilization.
Oh, I see what you're saying. Yeah, right. So these aliens, maybe they were real, and all of these stories about gods and beings are legitimate accounts of what was observed or what was happening.
Right, and that's another theme in Star Trek is like they came down to these primitive worlds, broke the Prime Directive, and people are like, "You're gods." It's like, no, we have technology. It's magic.
Right. Yeah, I think that's a very cool concept too, because they would be so far advanced, it would just be mind blowing to a Neanderthal, let's say. Even the basic tech, like our technology, would be mind blowing to them. Yeah. Super, super fascinating, and I don't know what the answer is.
That's why we're exploring.
Yeah, and it's fun. So do you have a sense of what kind of like, you talk about like at the very beginning, we were talking about the universe and the Big Bang and stuff, like the possibility of a creator. So in terms of like the spirituality side of things and like creation and getting a little bit into the religion, how do you think the possibility of like extraterrestrial life, intelligent life would fit into something like that? Or is there anything interesting to be said?
Well, I think we've both mentioned and tried to avoid the idea of like interdimensional beings, because at that point it's like, okay, are you talking about angels or aliens or like multidimensional? Like if something's multidimensional, like how do you distinguish that from metaphysical?
Yeah. Or how would you even observe or measure that? For me, like as a scientist that likes to use my tools to measure things.
Right. Yeah. How would you even measure that?
Right.
So maybe, and I guess this is like the ultimate like agnostic answer is like, even if you buy into the Big Bang, like what started the Big Bang? Like, was it bubble universes? Was it God? Was it interdimensional aliens? Like,
right.
There's this like regress problem or the panspermia thing. It's like, okay, maybe an asteroid landed and started life on Earth, but where'd the asteroid come from?
Right. Chicken or egg. Yeah, I mean, that's the biggest one and the go-to, and it's hard to say much about it. I don't understand it, but I've watched Lawrence Krauss multiple times. I don't know, he's a physicist here.
Oh, yeah. I think Peterson interviewed him.
Oh, did he? Okay. But yeah, he's been around for a long time, and really interesting guy, and he basically, much smarter than me when it comes to this stuff, but basically says that there's some mathematical way to show that from nothing you can have something using some of his physical physics math,
like probability and
quantum stuff. Yeah, because once you get into some of that, it can be pretty strange.
Very strange.
Yeah. So I don't know. I would like to look into that a little more to have more to say about it. But I know there is some way you can have something from nothing using it. Maybe there's like some side door thing that can't be accounted for. But like on a philosophical level, it makes no sense.
Well, and then there's other, it's hard not to stand in awe at the wonder of the universe. So one other, we talked about fine tuning, like the fact that life is possible. We were talking also about how DNA has a certain mutation rate. And part of that's actually determined by the atomic structure of the DNA molecule. Like there's a bond, there's a probability, which is connected to this like uncertainty randomness thing, but that's built into the structure of the universe.
Yeah.
So the structure of the universe allows for this DNA to exist and bond in such a way that there's some probability of mutation.
Which allows for the entire process of evolution to occur.
And life.
In life.
Yeah.
Yeah. And it's like this quantum tunneling is what it is. And there's some probability to where like these particles can just spontaneously like pass through matter and cause an error in how these different things are bonding. The quantum effect. It's just like crazy.
And there's another thing too. Peterson cited. I haven't looked up the paper, but he thinks it should win a Nobel Prize. He's probably right. And the idea is that the mutation isn't like equally probable. There's like the core DNA, which has like error correcting code and almost never changes. And then you have like fringe DNA, which has a higher probability of changing. And so there's like a hierarchy of mutation possibility.
Yeah. Well, I think it's not that the DNA itself is more stable, is that there's actually structures. There's like DNA structures around that preserves that portion of DNA more so. It's like they've upgraded their armor defense around that. But the DNA is just DNA. You know what I'm saying?
Well, I know they have the transcription machine things.
But it's not like this strand of DNA is like better than or stronger than this one for whatever reason.
Well, I'm curious to check it out because that's the way it sounded. And that's just mind-boggling in and of itself.
Yeah. I guess there could be more stable patterns. But
well, for example, people cite statistics like, the difference between chimp DNA and human DNA is like 0.1%.
Right. Yeah.
Which means we're almost the same in terms of DNA.
Yeah. And most of it is just noise, or we don't know what it is, but just like non-coding DNAs. So it's there, but it's like just not doing anything that we know of. Yeah. So there's a large chunk of it that's not doing much, but the stuff where the action is going is much smaller. And even then, yeah, there's a small difference between us and chimps. And this is the other thing too. So like you have genetic warfare at the same time. So there's not just like the stable stuff that is not as prone to mutation, let's say, and maybe it's more fringy stuff. But you have viruses coming in and trying to inject their DNA into your shit.
Right.
And that can cause some other kinds of weird evolutionary processes to occur.
Oh, yeah, for sure. And then you have like the kingdoms, right? Because you have like the fungal kingdom and the plant kingdom and the animal kingdom. And like some animals eat plants and, fungus eats animals. And
it's wild.
And they all use DNA, but they have like their own kingdom that they... And I'm sure you've seen that like... branch thing that like this branch goes here and then that branches. I think it's called like the tree of life or something like that.
Phylogenetic tree. Yeah. Yeah, it's crazy. And to think, we just talked about game theory last time. So you can think about these different kinds of organisms or players as like having some kind of self-interest to survive and expand. And it's like that battle between all of these different things, having like the viruses want to survive and our cells want to survive and the fungi want to survive, and they're all either like battling each other for whatever reason and feeding on each other or having some symbiotic relationship.
That's the other thing I was going to mention. There are a lot of crazy symbiotic relationships like lichen or slime mold. Look that thing up. It has this bizarre life cycle, or like jellyfish life cycle. Like what in the world? And then the other one that fascinates me is plants. So they have these chloroplasts that are like engines that convert sunlight into energy. It helps them to make energy for the plant. But the chloroplasts are, they think, like the mitochondria. They used to be algae that was taken into the plant cell to like be an energy source for the plant.
Right. So you could think of it as symbiosis, or maybe the plants have enslaved the chloroplast to, like the Matrix with the batteries. So these chloroplasts, let me out!
Make us energy.
Suck the energy from them.
So I would categorize that as symbiosis,
I know. I'm just trying to be facetious.
But no, we need more humor, so keep it
a
up.
little bit of... Yeah. So they've been taken prisoner and raised.
But yeah, like if you study like gut biomes and like, yeah.
It's okay. So all of this is like the diversity and how life evolves and all these moving parts. It's so crazy complicated. And all of this is happening in one planet.
Right.
So, and it's like that kind of stuff. Look at the diversity of all these different things coming out. You know, we've only had one that we know of, human Homo sapiens, that are able to have this kind of intelligent prefrontal cortex and to make things and to really like advance. But to me, this seems like if you just have some basic building blocks, like this diversity is just immense. And it seems like it's not too far-fetched to think that that's happening. Like if it is happening somewhere else, it's probably like has an equal amount of diversity and kind of possibility for intelligent life. So just thinking about the whole DNA, genetics, evolution thing, for me, that doesn't seem like such a delicate process anymore. When you look at all the different things, it seems very robust.
Say that again?
Like the whole, like, once you're established and you've got like DNA molecules, for example, and you have like cells or multicellular organisms, it doesn't seem so far-fetched to me that
life finds a way.
That it's not as fragile as we're thinking. It's actually extremely robust, and there's so many things that are happening. And like, if you push the system really hard one way, it's just gonna like wrap around and adapt.
Worms and like acid trenches under the ocean that like thrive off of thermal energy and acid.
Right. Okay. Or even let's say there was a thermonuclear war and all life was destroyed. Just humans are dead, and
the cockroaches.
Right, the cockroaches. You'll still have some soup left over. Yeah, and then those will evolve to be the aliens that are killing people or something. I don't know, but what I'm saying is
it'll be the planet of the roaches.
Yeah, roach planet.
And then they'll find human dolls.
Yeah. So I don't know. I think life is much more robust than I give it credit for. Starting, it takes a long time, and chances of it happening are pretty low. What's also kind of creepy is how much of a understanding we're getting of genetics and the tools that we're developing that can actually intentionally modify things in the specific ways to get what we want.
Oh yeah, like AI that models proteins.
Or just like basically genetic engineering. Like you use a lot of genetically mutated mice in the lab.
Like deliberately,
yeah, to do stuff that makes research easier or more interesting, or to answer a question. So, like, if a extraterrestrial intelligent civilization existed, they could basically, I'm guessing, have a complete mastery of the genetics and make whatever they wanted. It's like, if you know all the building blocks and everything, why don't you just make
biological art?
Whatever? Yeah.
Designer DNA.
Yeah. At some point, the evolutionary process is too slow, and the organisms that came from evolution are now like accelerating it even faster, which is wild. So, a couple more things that I think are really fascinating along this topic is I've heard the argument that if life did exist on other planets with slightly different kind of conditions and circumstances, what are the probability that it's going to look similar to life on Earth?
Right, the convergent evolution idea.
Yeah, or equal finality kind of thing, where maybe the DNA structure and this like quantum tunneling thing with this built-in amount of genetic mutation required for evolution, maybe that is so specific to those atoms and molecules and the elements that you can't really have another way to do it, and that would make sense.
And the counter argument to that is that there's so much randomness that the things are going to be so radically different.
Yeah. Well, you can't expect it. I mean, who knows what's possible? Yeah. But I've heard some really compelling arguments that like this carbon-based, 6 bonding structure and this like GTAC or whatever, those pair bondings are like
AGCT.
are so unique and specific just on the atomic elemental level. Like, how would you even engineer something that can contain that kind of information with the built-in spontaneous mutations that are required?
I know, well, I've heard that you can do similar stuff with silicon.
I have heard that,
but I haven't like researched it.
Yeah, there's something wrong with it, but it seems feasible. I think carbon is 6.
It's like a hexagon.
Yeah, and silicon is 8, so it's pretty close. But yeah, I've heard of that. Silicon life would be something totally crazy. But I like the idea that I'm more favoring right now, just in my intuition and my feeling and my understanding of all these systems, is that if there was life on another planet, I'm guessing it's probably going to look pretty similar to what we have here. At least with the DNA and the way things evolve through mutations and the way they organize atoms into molecules to create proteins. And then if you go with that argument into perpetuity, maybe they'd even have 2 arms and 2 legs. Like, maybe it could be crazy similar just because of the starting conditions and the specificity and what the kind of system that you need to get to that space. Basically, everyone has to take the same path. I find that compelling, personally.
Yeah, it's possible. And I was also just thinking too about like the whole algae into plants thing. And it's conceivable that never happened, and that we just have like fungus and bacteria. But the argument, who knows, but like you could argue that you couldn't have mammals and land animals without plants. Like, you'd need the ocean for protection. And
not only that, the oxygen that the plants are producing. And then now you can have these oxygen using animals, which are
right, the cycle. Right. So carbon dioxide to oxygen and vice versa.
Yeah. And there's a whole other thing to where, like, now if you can utilize oxygen in your biological process, like metabolism, then that's a whole game changer too. Because, like, the plants were using CO2 mostly. And yeah, I guess that was the way to get the animals out of the water onto the land. Get the oxygen in the atmosphere.
Yeah, so I guess my initial imagining was like, what if the plants never happened? And then you could argue, well, there'd be no animals. But who knows? I mean, all of this is conjecture.
Of course. Yeah, and then, what if the plants didn't, probably wouldn't have happened. But then, for me, it's like, the plants happening was inevitable.
Or one of the, what do you call it, bottlenecks or...
Oh, yeah, filter. Could be. Yeah. But yeah, so to me, the plants happening was inevitable. It's just a matter of how much time does it take, right? If everything's like a probability distribution, it's always going to be non-zero in my mind. And if it's non-zero, just give it like
a billion
3 billion years.
Yeah.
That's it.
Give or take.
The only thing is, within those billion years, let's just cross our fingers that no asteroids are coming down to jack things up or like do a reset or like other kind of catastrophes, some kind of crazy solar flare that just like cooks the earth or does whatever. There are so many things that you need a very long time to get there, and you will get there eventually, but you need to be unperturbed. And so it's things like these Jupiter planets that act as asteroid vacuums that you need. The other thing is like a molten core with an electromagnetic field.
Right, to protect.
That's also, to protect from all this other kinds of things. Fascinating stuff, and I'd like to see where it goes. I haven't heard too many new ideas, or like, is SETI even still in operation?
I don't know. Maybe. I mean, it might be kind of like NASA that was like seems to be superseded by SpaceX and like all these private enterprises rather than government organizations.
Yeah. Well, I think SETI was definitely a Carl Sagan kind of baby. I think he started that, and he was also very much like the public figure when it comes to the space exploration and travel. So people could get into it if it was like, we're going to send Voyager out with like the golden discs to try to talk to other races, or we have this thing we're going to try to see if we can find intelligent life elsewhere. And it was more of like a marvel that a more average person who wasn't into the science of it could like be excited about it.
Right.
Yeah.
And hopefully get on board, support it, encourage it.
Yeah. I know. So there's like, you've heard of the James Webb Telescope that came out?
Maybe.
It's like this huge space telescope that's
so like in Puerto Rico or
no, so
Hawaii?
it's a space telescope.
Oh, gotcha.
So the Hubble was the first one that's orbiting Earth. This one is like at this Lagrange point, is what they call it. It's some like neutral gravity between the Earth and the Sun.
Yeah.
Area. Anyways, it's this huge scope, and it's like what you do. It's not just like some person's running the scope and then they can choose what they want to do with it. There's like a huge committee, and there's like all these researchers that have like projects or ideas that they want to use it for. And I think I heard in the news a couple of them had some time slots for specifically looking for like science of extraterrestrial life, which I don't know. So I guess in the news maybe we'll see something that could be compelling. Yeah. Or even like the Mars missions and Europa, even in our solar system, there's been speculation of possible life there previously.
Or Mars.
Mars, for sure. Yeah. All we have to do is melt it out, the ice caps, and it should have plenty of water. Or maybe it was. Maybe Mars was the spermia that planted Earth.
That could be.
People have talked about that.
A lot of people thought about that, yeah.
Cool.
But now we're going to sperm them back.
Yes. Yeah, Elon splooge.
The seed of life.
Yes. Good stuff. All right, so how are we feeling? Got any more to add or any other thoughts?
I'm out at the moment.
Yeah. We went on so many tangents, but this is one of my favorite topics, and it's fun and it's interesting because you can think about it in an intellectual way and get serious about it, but then you can just kind of play around, and just think of the possibilities, which I think is a good exercise. Sometimes things can get just too serious and just like...
And maybe a little dry. Yeah.
A little dry. Yeah, so...
All right, well, thank you all for listening, watching. If you enjoyed the content, you'd like to see more, like and subscribe. And leave comments, questions. I'm going to spend a lot more time focusing on the channel and trying to get people engaged. So, yeah, tell us what you think.
All right. Goodbye, everyone.
And remember, always be curious.
Always be curious.